My name is Václav Vystrčil, and I work for a Technical Institute of Fire Protection in Prague. And today I will talk about the practical use of fire models within the Fire and Rescue Service of the Czech Republic. So, okay. First short outline of my presentation. I will briefly introduce you what exactly Technical Institute of Fire Protection is. Then I will give you a short overview of a system of fire investigation in Czech Republic, because the fire models are used mainly for the investigations, because a fire and rescue service don't deal with the building designs. That's what fire engineers do. So that's why I'm talking more about the investigations. Then I will talk about some main challenges in cooperation between the investigators and the fire modelers. And then I will show you a case study of one fire which we were part of investigating, and we did the model of that fire. So Technical Institute of Fire Protection, we are here in the Czech Republic. The Technical Institute of Fire Protection is a part of General Headquarters of the Fire and Rescue Service of the Czech Republic. It's based in Prague. You can see our building on the picture. And the main tasks of the TIFP are three. It deals with the testing of technical equipment for firefighters, if they are safe for them, if they are safe for use. Then it does research and development in the field of fire protection. I'm not going to cover this today. My colleague will have a presentation on Wednesday, so we will more cover that on Wednesday. And the last thing is the fire investigation in a special cases. So how investigation works in the Czech Republic. It's always cooperation between the fire investigators from Fire and Rescue Service and then police. The Fire and Rescue Service experts investigate the cause of the fire, and then the experts from the police investigate who is responsible, if the crime was committed or not, and it's this kind of a cooperation. Czech Republic is divided into 14 regions, and each of this region have its own fire investigating unit. So TIFP is not involved in all of the cases, but in some of the special cases. For example, when fire caused some significant property loss, or if it led to multiple fatalities, or if some advanced examination of different kind of samples is needed. And also, the fire model can be requested. It's in two cases. Either if there is some hypothesis about, for example, amount of the ignition source, or about the location of the fire origin, the fire model can help to prove or disapprove this hypothesis. Or the second case is when we want to show the difference between the actual fire that happened and, for example, the fire, if all the fire code requirements would be fulfilled. And this would be also the example of my case study. So now, a few words about the cooperation of fire investigators. The problem is that they usually have kind of unrealistic expectation what can be proved or shown by the fire model, and they usually have like really general questions to be answered by the fire model. You can see the example of that question. It's the first one. This is from one of our real cases. There was explosive device placed in a bus, and it did not ignite. But the question was, what would happen if it would ignite? So I mean, you cannot answer this by the fire model. So we had like long discussions with the investigators, trying to find what kind of answers would help them, but can be answered by the fire model. And we figure out these questions. We show that we, for example, can try to simulate one piece of luggage in a baggage compartment and show what the temperatures could be in the baggage compartment, and these kind of questions. And they then found it helpful for their investigations. So, and now I switch to a case study. This case study is about the fire in a nursing home. It happened about 2 years ago already. It was quite old building from the year 1985. It was converted from the home for elderly people to home for people with the mental illnesses, but no special changes in means of fire protections were done. There were 34 clients accommodated, but for these 44 clients, there was only one member of staff during night. The fire started between 4 and 5 a.m., so quite early in the morning, and the majority of the clients were still sleeping. It started in a common room, but the common room was the same fire section as 5 rooms for clients, for 17 clients. There was no fire detection in that building. There was no obligation to have one. And this fire resulted in 8 fatalities, and 5 clients were seriously injured. So it was one of the most severe fire in the last 30 years in history of Czech Republic. So why we did the model? The investigation showed that the fire was set by one of the clients who set the small pillow on fire on couch. So the cause of the fire was quite obvious, and the direct offender of the fire was found not responsible because of his mental health. But the second problem was that the fire could propagate for almost 30 minutes unnoticed because there was no fire detection. The member of staff was in a different part of the building, and this led to this long time led to this like deadly rate of that fire. So we were part of the investigation of possible violation of the building codes. This investigation after 2 years is still ongoing, so I cannot talk too much detail, but I will show you the details of the model. So we were asked to show the difference between the fire that happened, we call it real fire, and between like kind of hypothetical fire if all the building codes would be fulfilled. So we have the same geometry. You can see it on the slide. We modeled only the common room and the holes where the smoke spread in the real case. The fire started in a common room. You can see the red burner, and in case there's supposed to be a free fire section in the model, the staircase and the 2 holes, but basically the fire doors between hole and 2 were even not installed, and the fire doors to the staircase were open. So I will show you later how smoke spread. And in our ideal fire, we used the same fire source. We put it in the same common room, but we, by the obstacle, we tried to simulate the fire doors between the hole 1 and 2, and also the fire doors to the to the staircase. Also, this case was unique in a way that we were on a place from the beginning of the investigations. We had a chance to visit the place few days after the fire, so we could see by our own eyes the geometry and also some traces found on the place. And we found the smoke layer as one of the best things to calibrate our model, and also with help of the fire investigators, we found some traces of the heat damage on various items, such as this switch, to kind of calibrate our model. So I would say the most challenging thing for this model was how to determine the fire source because we didn't have much of the details. We assumed that the fire was ventilation limited because the fire occurred during the winter, and also the building was equipped with the well-sealed windows, and we derived the maximum heat release rate from the maximum available oxygen. We know that there were 3 windows in the common room. All of them broke. We found it from the video footage. We kind of have an idea of the time of the beginning of the fire from witnesses, and the rest we approximated as a T-scale fire. So after a few calibration, we obtained the smoke layer height from that model, and we ended up with the deviation about 20 centimeters from between the model and what we've actually seen on the place. So we were quite happy with that, and we continued with that fire source. And now I have a video of the smoke spread. I mean, for all of you here in audience, it's obvious that if you have a building with the smoke door with the fire doors, the smoke doesn't spread to like after the doors. But because during our cooperation with the investigators, we showed that even this really simple visualization of smoke can be beneficial for non-fire experts to show how serious can the consequences can be if you just remove the fire doors. So there is not really big science behind that, but we just use that as a visualization what would happen if you remove the fire doors. Also, we add the basic default smoke detectors into our simulation to kind of show how the spread would be, how the fire would be different if the smoke detectors would be installed. And we ended up in times in a range of seconds or minutes, which is significantly less than this 30 minutes when the fire was noticed in a real case. And now some consequences after the investigations. There are, let's say, 2 parts. The building itself was reconstructed, but there were some changes done to the building. The internal layout was changed, so the common rooms are now the separate fire sections, and also the building was equipped with the smoke detection systems, and the fire doors were installed in the correct places. And now the second part is that there was a kind of a huge discussion how to prevent such deadly fires in the future, and it ended up in a change of fire code in the Czech Republic, and now all the buildings of this kind have to be equipped with the smoke detection system, either a smoke detection system if more than 50 clients are present, and or at least autonomous smoke detections if less than 50 clients are present. And this change was applied retrospectively, so in 3 years, all the buildings of that kind have to be equipped with that fire detection system to prevent such fires in the future. So, I mean, our model was one of the things which kind of helped to convince the people who are changing the fire codes in the Czech Republic to do that change. So we are quite happy that we could be the part of that investigation, and that our model kind of helped to improve the safety of that buildings in the Czech Republic. So that's all from me. Thank you for your attention, and if you have some questions, I'm happy to answer them.
So we did have a question here, and I'll wait for my page to load. Not make too much noise in the microphone. We don't have a lot of time for questions, so we have, I think, 2 or 3 other groups in the hotel, and we're trying to get all of the people through the lunch at the right time, so we're not overlapping too much. So we need to go a little bit short on that, but let me switch back here to the event, Q&A. The question was, have you met a situation that an actual fire in the building done by the codes was different from the fire model that was also done by the codes? And if yes, what were those differences?
Well, usually, I mean, we are asked to do the model in like really, let's say, fatal cases when there is at least one violation of the code. So we don't do much like models which are right, let's say. Mm-hmm. So we don't have much experience with that.
Okay, okay, good. And one more question, anybody in the room? Up front.
I guess I put it in the wrong way because you didn't see it. Thank you for your presentation. I have one question. Fire doors are not hermetically safe. They have a leakage rate that is defined by pressure. Mm-hmm. How did you model it, and did you take it into account?
Well, we did not take it in account in that model, but in different models we used the FDS pressure zones and these HVAC systems for the modeling the leaks through the doors. But I mean, especially for that model, they also in a new design, they've put not just the fire doors but also the fire doors which are also like smoke sealed. These what do you say? I now have the word in Czech, but yeah, there are like different levels of. You can have kind of ordinary fire doors, but then you can have these special, which are also have like special seal for the smoke also. So they used these in the new design of this building. Mm-hmm. Yeah, mm-hmm. True.
Okay, thank you.